Deep in the heart of the American continent, beneath mountains in Colorado, under the flatlands of Nebraska, inside rock formations in Virginia and Maryland, and under the streets of Washington, D.C. itself, a network of hardened underground facilities runs continuously without pause. These facilities were built during the decades of the Cold War, when nuclear weapons existed in quantities large enough to destroy every city in the United States, multiple times over. The planners who built the network were answering one question: if the surface of the country is destroyed, what survives underground and what can it do? A beautiful nightmare for structural engineers and civil defense planners. The challenge? Build facilities that can survive a nuclear weapon detonating within 1 mile and continue operating in the aftermath. This is the continuity of government infrastructure, the hardened bunker network built to keep the United States government alive after a nuclear strike. In 1950, the mobilization began. The Atomic Energy Commission and the Department of Defense commissioned a network of studies and engineering assessments that defined the requirements for survivable government facilities. Over the following decade, thousands of engineers, geologists, and construction workers were deployed to sites across the country under security classifications that prevented any discussion of their work outside government channels. The rock beneath Colorado Springs was chosen as the primary command facility site. The granite here is among the hardest in North America. Weapons effects calculations showed that a granite facility buried under 1,000 feet of rock could survive the blast wave and thermal pulse of a nuclear weapon detonating on the surface directly above it. The drilling and blasting began in 1961. The clock starts now. The Cheyenne Mountain Complex is the most visible element of the network. 2.5 million tons of granite were removed to create the cavern complex inside the mountain. The primary excavation follows the natural grain of the granite, using the rock's own structure to support the cavern spans. Blast holes were drilled in patterns designed to control fracture propagation, breaking loose the rock that needed to move while leaving the surrounding mass intact. Each blast cycle advanced the excavation by 2 to 3 meters. The blasted rock was removed by loader and truck through the access tunnel, while the next drill cycle prepared the face ahead. The process repeated around the clock for 3 years until the main cavern complex was complete. The interior structures of the Cheyenne Mountain Complex sit on springs, not symbolic springs, actual mechanical coil springs, over 1,000 of them, each one rated to absorb a specific share of the blast energy that will propagate through the rock and attempt to shake the interior structures to pieces. The building frames inside the cavern rest on these springs rather than on the rock floor directly. When a blast wave hits the mountain, the rock moves. The spring system absorbs the movement before it transmits to the building frames. The buildings shake less than they would on rigid mounts. The equipment inside continues operating. The people inside survive. The spring system was engineered to the predicted blast overpressure at the design standoff distance. The springs are inspected and tested on a maintenance schedule. They have never been tested by an actual nuclear weapon. They were designed for that test. They wait. The blast doors that seal the access tunnel to the Cheyenne Mountain Complex are the most famous engineering elements in the network. Each door is a steel plate 25 tons in weight, mounted on hinges that allow it to swing open and closed, and designed to seal against the blast pressure of a nuclear weapon detonating at the design distance. The seal mechanism compresses against the door frame when the door closes, preventing the high-pressure blast air from pushing through the gap between door and frame. The closing mechanism operates hydraulically and can close the door in seconds from a remote control position inside the facility. The door can also be operated manually from the local position. The hinges are maintained on a regular lubrication and inspection schedule. The door closes and reopens correctly on every test. It has sealed the facility on one occasion in its operational history during a construction accident in 1965 that sent dust and debris into the access tunnel. It performed as designed. We dig not just into mountains, we dig beneath cities. The Mount Weather Emergency Operations Center in Virginia sits inside a mountain 40 miles from Washington, D.C., built to house the civilian federal government in the event of an attack on the Capitol. The excavation at Mount Weather removed millions of cubic meters of rock through adits driven horizontally into the mountain slope, opening chambers large enough to contain entire government departments with their filing systems, communications equipment, and senior staff. The facilities include offices, dormitories, cafeterias, a hospital, a power plant, a water supply system, and a sewage treatment facility. Everything needed to sustain a functioning government for an extended period without any resupply from the surface. The design standard is 90 days of full operation with no external support. The underground power plants that supply electricity to the hardened facilities use diesel generators isolated from the surface fuel supply. Fuel storage tanks underground hold months of operating fuel. The generator rooms are designed with acoustic isolation to reduce the sound signature that could reveal the location of a facility to reconnaissance systems. Exhaust is vented through channels that disperse and filter the heat signature to minimize detection from the air. The fuel storage is pressurized to prevent contamination from groundwater intrusion. The generators are maintained on a rotating schedule that keeps them in operational readiness at all times. A generator that has not been run for weeks may not start when it is needed. The maintenance schedule ensures they start. The communications infrastructure connecting the bunker network to the military command and control systems is the most hardened element of the entire structure. Underground cable runs carry encrypted communications between facilities through cables buried deep enough to survive blast effects on the surface. Above-ground communications towers at the facilities are designed to survive wind loads and overpressure from weapons effects. Emergency communication systems use very low-frequency radio transmissions that can penetrate soil and rock to reach submarines at sea from transmitter facilities hardened against attack. The communication links between the hardened facilities and the systems they must command are the final test of the network's value. A facility that survives an attack but cannot communicate with the forces it is supposed to command serves no purpose. The critical obstacle in the construction of the Raven Rock Mountain Complex in Pennsylvania, the alternate Pentagon facility, comes during the excavation of the main access tunnel in 1952. A section of the tunnel encounters a zone of heavily fractured rock that was not identified in the pre-construction geological investigation. The fractured zone cannot be excavated by the standard drill and blast cycle because the blast waves propagate unpredictably through the fractured material, causing overbreak and roof falls that leave unsafe cavities above the tunnel profile. We cannot advance on schedule, and we cannot leave the fractured zone without a permanent support solution. Roof bolts are installed through the fractured zone, reaching into competent rock above and anchoring the loose material in place. Steel arch ribs at close centers support the tunnel profile through the fractured length. Shotcrete seals the fractured surface against further loosening. The tunnel advances through the problem zone at reduced rate. On the other side, the ground returns to competent rock and the rate recovers. The facility is completed on schedule. Cheering. Raven Rock opened in 1953. Cheyenne Mountain became operational in 1966. Mount Weather has operated continuously since the 1950s. The facilities have been maintained, upgraded, and expanded through the following 7 decades. The command and control systems inside them have been replaced multiple times as technology changed. The rock around them has not changed. The springs under the Cheyenne Mountain buildings have not been replaced. The blast doors at the access tunnels have cycled open and closed thousands of times for maintenance access, personnel movement, and equipment delivery. The mountain does not care. The rock absorbs the weather and the years and the occasional earth tremor without change. The facilities inside it operate today as they did in 1966, serving the same function they were built for in a world where the weapons that prompted their construction still exist. Visitors touring the declassified portions of the Cheyenne Mountain Complex walk through the access tunnel and emerge into caverns that are larger than expected and quieter than expected. The spring mounts under the building frames give the floors a faint resilience underfoot that no other floor in any building has. The blast door at the tunnel entrance is open during tours. Visitors touch the steel. They push on it. It does not move. The door weighs 25 tons. It swings on its hinges with a force that one person can provide, because the balance point of the design puts most of the weight at the hinge axis. The engineering that designed that balance was done in the 1950s with slide rules. It still works. The bunker network was built during the most dangerous years of the 20th century to ensure that the United States government could survive the worst event the century could produce. That event never came. The network has never been used for its primary purpose. The facilities continue operating, maintained and ready, beneath mountains and cities and fields across the American interior. A testament to what engineers build when the brief is, build something that survives everything. Where there is mountain rock, now there are springs and blast doors and governments that will not die. If projects like this move you, subscribe so you do not miss the next one. Drop a comment and tell us where in the world you're watching from. The water supply systems inside the hardened facilities are engineered to the same survival standard as every other element. Wells drilled from inside the mountain into water-bearing rock formations provide a primary supply that requires no external infrastructure. Water treatment plants inside the facilities process the well water to potable standard. Storage tanks provide buffer capacity against periods of high demand or well maintenance. Wastewater treatment facilities process all wastewater to a standard that allows discharge to the natural drainage within the mountain without creating a detectable surface signature. The water system for each facility is a closed loop that requires no connection to any external utility. It operates independently of the surface infrastructure that would be destroyed in the attack scenario the facility is designed to survive. The food storage systems inside the continuous operations facilities hold supplies calculated to sustain the full occupancy population for the design duration without resupply. The food is stored in sealed containers in temperature-controlled spaces that extend the shelf life of the supplies to exceed the design period. Rotation schedules replace the oldest stored food with fresh deliveries before the oldest items approach their expiration dates. The rotation requires careful inventory management and regular delivery schedules that must not reveal the quantity of supplies stored. The food that arrives at the facility for storage looks like the routine provisioning of a normal government office to anyone observing the delivery activity from the outside. It is not routine. It is the maintenance of the food supply for a government in exile. The medical facilities inside the hardened installations are fully equipped field hospitals capable of managing trauma, surgical emergencies, and sustained medical care for the full occupancy population. The medical staff assigned to the facilities maintain their certifications and skills through regular training exercises. Medical supplies are replenished on the same rotation schedule as food. The facilities include blood bank storage, pharmaceutical dispensary, radiology capability, and intensive care capacity. The design standard for the medical facilities is that no medical condition that could be treated at a major urban hospital should require evacuation of a patient to a surface facility. All necessary care is delivered inside the mountain. The security systems at each hardened facility operate on a tiered access control model that limits knowledge of the facility's interior layout and capabilities to the personnel who need that knowledge to perform their functions. Physical access control uses multiple barriers between the access tunnel entrance and the operational spaces inside. Biometric verification, code input, and physical checkpoint inspection combine to create an entry process that takes several minutes, even for fully credentialed personnel. The barriers are designed to defeat both external attack and internal compromise. The blast door is the first barrier. It is not the last. These facilities have been maintained under active government programs for 70 years. The Cold War that built them ended in 1991. The facilities remained operational through the end of the Cold War and continue operating today. The threat environment that originally justified their construction changed after 1991. The threat environment that justifies their continued operation today is different in character, but not in consequence. The facilities were built for the worst possible day. That day has not come. They wait. The electromagnetic pulse hardening of the facilities is the least visible and most critical element of the survivability design. A nuclear weapon detonated at high altitude above the United States would generate an electromagnetic pulse that would destroy unprotected electronic systems across a continent-wide area. Every circuit, every computer, every communication system on the surface would stop functioning simultaneously. The hardened facilities are shielded against this effect by a continuous conductive enclosure, a Faraday cage, built into the structure of each facility. Every cable entering or leaving the facility passes through filters that prevent the pulse from entering on the wires. Every penetration through the facility wall is sealed against electromagnetic propagation. The facility's internal electronic systems can operate after an electromagnetic pulse event that has stopped every unshielded system on the surface above them. The communication links to other facilities that also survive are the foundation of a command and control network that functions when the surface network does not. This is the core of the continuity of government function. The government that continues operating is the government that can still communicate with the forces and systems it commands. The facilities in this network represent the most consequential investment in preparedness that any government has ever made. They were built with the acceptance that they might never be needed, and the knowledge that if they were needed, nothing else would matter more. The engineers who designed the spring mounts and the blast doors and the Faraday shields and the well systems did their work in the knowledge that a design failure under the conditions these systems were built for would have consequences beyond any engineering context they could fully imagine. They designed conservatively. They tested thoroughly. They maintained continuously. The network sits beneath the country that built it, unchanged by the decades above it, ready for a day that no one wants to come.